All right, folks, so back to playing games with the double slit apparatus. What we've covered so far is basics of interference, optical path versus geometrical path, the relation between phase difference and path difference, and given that all things are equal, the only thing that will dictate whether we have a maximum or a minimum is this idea of the path difference. And the path difference is this minus that reduces to this, which is d sine theta. If that's equal to m lambda, we have a constructive interference. If that's equal to m plus a half lambda, we have destructive interference. Right? So, and we played a game where we wanted to see what the angular position of the seventh maximum or minimum would be, 7 lambda over d. Start putting in numbers and see where these things are. Next, we're going to play a game of finding out what, okay, so if I have the angle, theta, for whatever interference I'm looking at, interference, order of interference, maximum or minimum, can I get the distance on the screen here? Well, for that, I'm going to add it right here because I don't want to interrupt the flow, okay? So what do I have here? This is angle theta, right? And this is y and this is d. So y over d typically is tan theta, but the angle is so small that we can call it sine theta. So a really cool thing now is that sine theta sub m, okay, let's say we're looking at the mth maximum is m lambda over d, but that's also equal to what? We're going to say that sine theta is equal to not this over that, because the angle is small, we can call it this over that as well. That's the approximation we're making in. That's equal to y sub 7, the actual position on the screen is the 7th maximum, divided by d. So this is for maximum, right? So if that's the case, then y sub 7, or y sub m, call it m here, okay? Y sub m is equal to what? M lambda d over d, okay? So I have here, I'm going to start over here again. I don't have, you know, I don't want to move boards because it's going to get confusing for the camera. Y sub m is equal to m lambda d over d. That's for the mth maximum. Okay? All right. Can we tell what y sub m plus 1 would be? Like say we're looking at y7, y8. Y sub m plus 1 is equal to m plus 1. Let's replace m with m plus 1, lambda d over d. And that's also for maxima. Okay? Because of, you know, this corresponds to maxima. Okay, so we've gone from looking at the angular position to actually looking at the actual position on the screen, and that's why. Okay, the actual height above the main axis, above the midpoint, y over d. From the y over d is equal to sine theta, and that's m lambda d over d for that maximum. So we have something interesting now, in that if we take the difference of ym plus 1 minus ym, that is called what? So y7 is here, y8 is there. Call this 7, call this 8, and you take the difference of these guys, ym plus 1 minus ym is equal to lambda d over d. This guy here is called the interfringe distance. And that's an important concept in interference, called the interfringe distance. You know, we are going to play games with it next. Now let's say that you could do this experiment, immerse this whole business in oil or water or whatever. What happens to the interfringe distance that way? Okay, how is that going to change things? Right? Do you know? Can you tell? If I put this, immerse this in oil or something, what's going to change here? D is not going to change. Is that going to change? Right? So that's something to look at. So we've covered the interfringe distance. Next, we're going to do the following. Okay, guys? We're going to play games with the optical path versus geometrical path. And for that, what I'm going to do is, first let's pause here. And then there'll be another video coming up shortly.